So in today's class, we are going to continue solving physics tutorial sheet 2 on vectors, and specifically this is physics 10:15, and this tutorial sheet is based on vectors and it was prepared by the University of Zambia. Like we did in the first part, we were still solving the 2022-2023 intake tutorial sheet. Yeah, so I hope you guys will be following, and I hope you guys should be able to ask where you feel you are not clear, because that's why we are here, to push each other, and so that we make sure that we cross over smoothly. So that's the cover page, so make sure that you check up the same tutorial sheet, you solve all the questions, and make sure that you understand all the questions. Okay, so my first question in today's class is, in the figure below, a vector with a magnitude of 17 meters. So we have the magnitude of 17 meters. That's the first information. Is directed at an angle of 56 degrees. So we have this angle here, which is simply 56 degrees. All right. And then counterclockwise from the x-axis, what are the components? So this is a very nice and interesting question, such that we have been given this particular vector, and this vector, it is a vector which is this one. So this is a vector which we have been given. So this vector, it is having an angle which is 56 degrees. So this is 56 degrees here, if you observe very well. So this vector, remember, since it has moved 56 degrees, so we have the x-axis and also the y-axis. So if you look very well, let me just make some illustration on this particular diagram to help you guys to be able to remember. So this is the y-axis. If you observe very well, the one I'm shading in green color, and then we also have the x-axis, which I'm going to show using the blue color. So this is simply the x-axis. So with this information, we can understand that this particular vector, which is vector A, it is having two components, the ax, which is simply this guy, and also the ay, which is simply that guy. So with this in mind, the question is find ax and ay. So these are just the vector components of this particular vector. So you're going to say a. So if you look at ax, this is simply the a component of this particular vector. And I do remember we had the formula for how to find the x component of a vector. Can I have the answer on how you can find the x component of a vector? What is the formula? Ax is equal to what? Ax is equal to
vector A times
correct. So vector okay, vector A cos theta. All right. So from there, you can simply say ax is equal to, we have been given the magnitude of vector A, which is simply 17, and then we are going to say cos our theta is simply 56 degrees from the x-axis, from the positive x-axis. If you plug in that on your calculator, what are you guys having? 17 cos 56, what are you having? What are you having? Are we together?
9.506.
Correct. So AX is
I'm getting 9.506.
okay. So AX is equal to 9.506279359. So this is the value, so we can simply round off this value, collect to two significant figures. So we are going to say 9.5 meters, which are the units we are having there. So 9.5 meters is our solution for this particular vector when you talk about its x component. Then we can look for the y component, which is our b in this case. So for the y component, how do you find the y component? Taonga, what is the formula for the y component?
It is a
Okay,
sin theta.
correct. So when you talk of the y component, you are going to have ay is equal to a sine what? Sine theta. This is for the y component. So ay is simply equal to, our a is 17, and then you're going to say sine our theta is simply 56 degree. So ay is simply equal to, what value are we finding? I'm sure we are finding something like 14.1. Okay.
14.09.
All right. So the value for the y component of this particular vector is just 14.1. So with this in mind, we can easily look for this particular question. So a second coordinate system is inclined by an angle 18. So we need to understand that there is another angle which has just been created, and this angle is 18.0. So this angle is this angle here, 18.0 degrees. Since this angle is equal to that particular angle, which is 18.0 degrees. Okay, so with this in mind, we can easily look for ay complement, which is this particular component, and then we can also look for the ax. This was supposed to be ax complement, so that was a typing error. So this is ax complement, and then this one is ay. So let's quickly solve the question. So for ax complement, we are going to move the same way, but in this case we are going to say a cos. Instead of just putting theta, we are going to say theta minus theta complement, because we are having a subtraction from this 56. We have this subtraction of 18 which is taking place there. So with that in mind, we can say ax complement is simply equal to 17 cos. You're going to say 56 minus 18. 56 minus 18. So ax complement is simply equal to, if you work out that, this will be 17 cos 38. 17 cos 38. So ax complement is simply equal to 13.39 or 13.4 meters. So that's how you can look for that particular question. Then the other one, which is our b, so for our b, we are going to say ay complement is simply equal to, we do the same thing, which is a sin theta, but in this particular case there is that complement theta which has come in, so we are going to say a sin, and then we are going to say theta minus theta complement, like that. So ay complement is simply equal to 17, simply equal to 17 sine. We know we are going to have the same thing, 56 minus 18 is simply 38. So ay complement is simply equal to 10.4 meters. So this is how easily you can do this particular question. I don't know if there are any questions that you guys have.
After all, is it not supposed to be 10.5 because the actual number is 10.46245.
Okay, so if you want, you can put 10.5 meters. Yeah, it's okay. Is that okay? Is it okay? Okay, so let's move on and look at the next question. Let's move on and look at the next question. So this question is, in the figure below, a heavy piece of machine is raised by sliding it a distance d. So we have a distance d, so this particular distance is 12.5. so this distance there is just 12.5 meters along a plank oriented at an angle of 20 degrees. So we have 20 degrees there to horizontal. So this is the horizontal guy there. Then how far is it moved? So how far is it moved? So if you look at this and also how the horizontal, how far is it moved vertically and also horizontal. So if you look at this particular vector, this is the same as you have, I'm redrawing this. Let's say you have this particular vector whereby you have this, and then this vector, it is, let's say, 12.5 meters. So that's what you have there. And then for this particular vector, you need to understand that you have the horizontal component, which is this one, and then you have the vertical component. You have the horizontal component and also the vertical component. So the vertical component can simply be this guy here. So this is the vertical component, which is just the height. So this height here is your vertical component, and the floor is just the horizontal component. So this is how easily you can analyze this question and how easily you can work it out. So this guy, the distance which we have been given, it can be said to be the what? It can be said to be vector d if you want, or if you want, you can put it as r as your resultant, depending on what you want to treat it with. So with that in mind, we can simply work out this question by saying this. Let's say we treat this as our distance. So this is our distance as our resultant, and then this can be our dx, okay, and then this can be our dy, and then we know the theta here is just simply 20 degrees. So with this in mind, we can simply know that here we are just looking at the vector component, which is the y component and the x component. Okay, let me redraw the same thing. So you have this part as your original vector, and then this resultant is having the x component, which is this one, and also it's having the y component which is in that particular direction, like that. So with this in mind, we know that this guy, the guy which is here, is 12.5 meters, and then there is simply 20 degrees, and this is d, this is dy, and then the other one is dx. So to find the vertical component, so the vertical component, okay, the vertical component is the same as the y component. The vertical component is the same as the y component. Okay, so in such a case, you can just simply say dy is simply equal to, so there you know it is going to be d sine theta, d sine theta. After doing that, you can simply work out by simply saying dy is equal to d is 12.5 and then sine 20. D is 12.5 sine 20. So dy is simply equal to, what are you having when you plug in? For those with calculators, what are you having when you plug in? Sorry?
4.275.
Okay, so 4.28. Okay, so 4.28 meters.
4.27525,179.
Okay, so we have just simply rounded it off, and that's the answer for the vertical component. So we can look for the horizontal component. We can look for the horizontal component, and this horizontal component is just the x component. Okay, so the x component is the same as the horizontal component. The x component is the same as the x component. So in such a case, you're just going to say dx is equal to d cos theta, d cos theta, and then you say dx is simply equal to 12.5 cos theta, which is 20 degrees. So dx, if you place on your calculator, it's going to give you something like 11.7 meters when it's being rounded off. 11.7 meters is the final answer. So that's it for this particular question, and that's how easily you can work it out. Do we have any questions, ladies and gentlemen? Do we have any questions? Are people around? Okay, so we can move and do the last part. We can move and do the last part. Okay, so with this question, it's a little bit tricky, and it's a question that most of you are supposed to give much attention, and please make sure that you ask where you are not clear. So all right, solution. So the question is, you are to make 4 straight lines. You are to make 4 straight lines, moves over a flat desert floor starting at the origin of an xy component or coordinate system and ending at the xy coordinate system, which is 140 meters and 30 meters. So in this particular case, you need to understand that the resultant, in this case, the resultant, so I'm collecting my information. So the resultant in this case is 140, okay, 140 comma 140 meters comma 30 meters. Okay, so this is the resultant. So if you look at this resultant, this is simply telling you that you have two components here. So this is the x component and this is the what, the y component. So the x component and y component of your moves are the following. So you already have the resultant, but you have also been given your moves in which you are moving. Okay, so let's quickly draw or gather the information and see how best we can understand this question. So I'm going to simplify this question in such a way that you guys will be able to understand and you guys will be able to solve the questions that I'll give you as assignments. Okay, so for this particular question, I would advise you guys to draw a table for components, to draw the table for component like we did in lecture 3 of vectors. So lecture 3 of vectors is the one we were dealing with the component of a vector. So after you do that, we can simply have this side the x component, this side we can have the x component, okay, and then the other side we can have the what, the y component. So we have the x component and also the y component. So that's the information we have at the moment. Now let's quickly look at how we can gather the information. So we have been told that the x component and y component of your moves are as follows. So you're having the x y x y x y x y. Okay, those are your particular moves. So you can start with x's. You start with x. The first x is positive 20. Guys, I'm using the table because it's the easiest and it's error free. In short, that's what I can say. It's very easy for you to get an accurate answer when you are using the table and like using the interval notation. So you pick this as your x, this is your x, this is your x, that is your x, and that is also your what, your x. So let's pick our x's. So you have positive 20. Remember the signs are very important. You have b, okay, you have b, that's the other one which we have, and then the other one we have negative 20, we have negative 20, and the other one we have negative 60. Okay, so those are the components that we simply have for the x coordinate. Then you can pick the y coordinates. You can pick the y coordinate. So if you pick the y coordinate, this is what you expect. So you have that one as your y, this one as your y, this one as your y, and that one as your y. So this one is 60. You put 60 there. The next one is negative 70. You put negative 70 there. The other one is cy there, and then the other one, it is what, negative 70. Is it negative 70? Yeah, it's negative 70 again. So you have negative 70 like that. So after you have this information, after you have this particular information, you can do what we were doing by finding the summation of all these particular vectors. You can find the summation of all these particular vectors. So for this table, it will help you to solve A and B. For this table, it will help you to solve A and B. Then A and A, for this part and that one, this one are very easy. These are things that we did initially. So for these ones, they will be very easy for you to work out because you have the x component and y component of the resultant. Remember, this is the resultant. This is the resultant which we have been given there. So what you are going to do, you are going to add. You are going to say 20 plus b minus 20. Automatically 20 and 20 have gone. So you are in this bracket, you are going to have b minus 60. So there you are going to have b minus 60. So here you have b minus what? Minus 60. This is the x component, ladies and gentlemen. Then the y component, you simply do the same thing. The y component, you are going to simply,
I'm unable
you are unable to, oh, okay,
the video.
okay, let me work on that. I think should be network. Okay, let me work on that so that